Hello scholars, our Module 1 Topic C work today involves the relationship between miles and kilometers. Miles to kilometers. Students in a world geography class want to determine the distances between cities in Europe. The map has a European publisher, which gives all the distances in kilometers. These students want to determine the number of miles between towns so that they can compare distances with a unit of measure that they are already familiar with. The graph shows the relationship between a given number of kilometers and the corresponding number of miles. So, what can we determine just by looking at the graph? Using the graph converting kilometers to miles, we can determine, one, that a mile is a greater distance than a kilometer. For any point along the graph, it takes fewer miles to measure any given distance. So a mile is a bigger unit of measure than a kilometer. Second, we can determine the number of miles is proportional to the number of kilometers because the graph is a straight line that intersects the origin. Since the graph shows us that the number of miles is proportional to the number of kilometers, that must mean that there is a constant of proportionality, K, between miles and kilometers. Part A, our job is to identify the constant of proportionality between the number of miles and the number of kilometers. So the constant of proportionality K is equal to y divided by x. So using my graph, I need a pair of x, y values that I can use to determine the constant of proportionality. And so at x equal to 8, I can see that there is a y value 5 that aligns directly on the grid. So I can determine an exact number of miles when kilometers equals 8. So 8 kilometers, x, corresponds to 5 kilometers, 5 miles, y. And so I have a constant on our map, or on the graph, 5 miles for every 8 kilometers. Now, if I choose, I could take this a step further and express the constant 5 miles for every 8 kilometers as a decimal by dividing 5 miles by 8 kilometers. But do you think that would be wise? So here's our constant expressed as a decimal. 5 miles for every 8 kilometers could be expressed as 0 and 625 thousandths. So which form of the constant do you feel it would be easiest to compute with? The fact that the graph is a straight line intersecting the origin also means that we can write an equation relating the number of miles y to the number of kilometers x. So what is the form of a proportional equation? So proportional equations take on the form y is equal to kx. So what will our equation that describes this relationship between miles and kilometers look like? So for our equation, we'll substitute the constant 5/8 for k. And so we have the equation y, the number of miles, equals 5/8 times x, the number of kilometers. This would be the form of the equation using the decimal form of the constant. Y, number of miles, is equal to 625 thousandths times the number of kilometers. So again, which number would you like to be computing with? 5/8 or 625 thousandths? And to move forward, be thinking about that choice, and we'll recommend using the fraction form of the constant 5/8. Question C. According to the proportional relationship, cities located 28 kilometers apart are how many miles apart? Think about your answer to that question out front. Should the number of miles be less than, equal to, or greater than the number of kilometers? So will our answer be less than 28, equal to 28, or greater than 28? To help us make sense of this question, what we need to imagine is that our graph continues past the values that we see. So along the x-axis, we have 28 kilometers. What we need to figure out is what number of miles would be on the y-axis. So if this graph continued to the point where kilometers x equals 28, what is the y-coordinate number of miles? And as we can see, the number of miles is always smaller than the corresponding number of kilometers. So in your estimate, you should have said that our answer must be less than 28. So our equation, y equals 5/8 times x, is what allows us to find data that we can't see on a graph or in a table. So graphs and tables have limits, but an equation is unlimited. We can find, given a value of x, we can find the corresponding value of y. I can substitute the known value of 28 for x. I know that there are 28 kilometers, so I substitute 28 for x, and I will multiply 5/8 times 28 wholes, or 28 over 1. So when we multiply 5/8 times 28, we arrive at 148, and I can simplify my answer by dividing 8 into 140. So after dividing 8 into 140, I arrive at 17 miles, and I have a remainder of 4. So what can we do with this 4? So I can take my remainder and express it as a fraction, so I would have 17 and 4/8 miles, and 4/8 is equal to 1/2. So we would have 17, y is equal to 17 and 1/2 miles, which you could also say y is equal to 17 and 5/10 miles. So do we feel that based on our estimate from before, do we feel that that is a reasonable number of miles given 28 kilometers? Question D. According to the proportional relationship, how many kilometers separate cities located 40 miles apart? So begin again your process of solving this problem with an estimate. So should our answer, given 40 miles, should the number of kilometers be less than 40, equal to 40, or greater than 40? Think about what would be a reasonable answer for the number of kilometers. Like before, we can make sense of this problem by referring to our graph. And we imagine that our graph extends past what we can see, and on the y-axis we have 40 miles. What number will be on the x-axis for the number of kilometers? So we're searching for this point along the graph. If we extend this pattern where y equals 40 miles, and our unknown is x kilometers. So we can see that along the x-axis, the number of kilometers is always greater than the corresponding number of miles. So our estimate should have said that our answer for the number of kilometers must be greater than 40. So again, we utilize our equation to find things that go beyond the limits of the graph. So we're going to substitute 40 miles for y. And so we have 40 is equal to 5/8 times x. And so in our classwork, we've shown x to be equal to y divided by k. So that would mean, what would that mean in this situation? So in this situation, that means that x is equal to 40 divided by 5/8. So here's what that problem translates to. 40 wholes, 40 over 1 divided by 5/8. So what equivalent multiplication problem can we write to solve that division problem? So that equivalent multiplication problem is 40 wholes times the reciprocal of 5/8, 8/5. So here we see the process to solve that multiplication problem. We multiply straight across and find 320 divided by 5. And 5 will divide into 320 64 times. So we have x equal to 64 kilometers. Do you feel, we go back to our estimate and go back to our graph, do you feel that that is a reasonable answer given 40 miles, that 64 kilometers is a reasonable answer? Question E. Describe what the point 0, 0 on the graph represents in terms of the situation being described by the graph. Now, what is each dot or point drawn on a graph? So each dot on a graph is a coordinate pair x, y. And it is a sentence in algebra describing the relationship between the x variable and the y variable. And so in this case, it's describing the relationship between the kilometers x and the miles y. So the point 0, 0 represents that when that 0 kilometers on the map equals 0 miles. So that would be a way to translate that point on a graph to a statement in English. Question F. Which point on the graph represents the number of miles that equal a distance of 1 kilometer? Write the coordinate pair for the point. So first of all, when we think about writing the coordinate pair, where will 1 go? Will it go in x or y? So referring to our graph, we know that on the x-axis we find number of kilometers. And on the y-axis we find number of miles. So given a distance of 1 kilometer, that 1 would be on our x-axis, and so our 1 needs to go into x's position in our coordinate pair. So how do we determine what y, the number of miles, are? If there is a 1 on x, what will be on the miles axis or the y-axis? One way to determine that y value would be to think about what value or what quantity always travels with x equal to 1. What is x equal to 1? What is always its traveling companion? So we've seen in tables of x, y coordinate pairs that in a proportional relationship we always find 0, 0, the origin. Whenever x is equal to 1, y is always k. We also see that in our graph. When x equals to 1, y is always k. So x equal to 1's traveling companion is always k, the constant of proportionality. So in this relationship between miles to kilometers, what is k? K, as we know from earlier questions, is 5/8. So for every 1 kilometer you travel, for every 1 kilometer you travel a fraction of a mile, 5/8 mile. So when x is 1, y is 5/8, the constant of proportionality. So a final way to determine that y value, we can always use our equation that describes the relationship. So we have y equals 5/8 times x. I would substitute 1 for x, 1 kilometer. Y equals 5/8 times 1, which equals 5/8. So again, y equals 5/8 mile. So our coordinate pair would be 1 kilometer, 5/8 mile.